we'll do now second module, the simplex method. That thing will start. Maxima z is equal to 6x1 plus 5x2 subject to constraints. The first constraint was x1 plus x2 is less than equal to 5. x1 plus x2 should be less than equal to 5. And second constraint was 3x1 plus 2x2 should be less than equal to 12. Okay, and as usual x1 and x2 should be greater than equal to 0. So this is the first example we have seen in the last class, where LPP problems, formulating the LPP we have started now in that. So now what we are studying model 2. In model 2 it's completely based on the simplex method, or if we speak in terms of this one 10 scheme, this unit 2 and unit 3 actually it's based on this simplex method. Okay, so in this simplex method now we are having one is algebraic method to solve the LPP problems, that is linear programming problem. We have a algebraic method, and other thing is we have a tabular method. So most of the time, even in 10 scheme also, we'll get most of the time with this only to solve the simplex method. Very rarely they will ask a questions where we need to solve through a algebraic method. So first we'll finish with this tabular method because it is easy to understand. So we'll start with the tabular method. Now we have seen how to solve this LPP. In the last class, we have seen how to solve the LPP by graphical method, right? But what is the problem with the graphical method? The main problem with the graphical method, we can solve this, we can use this graphical method only if there are two variables. If the LPP contains only two variables means what? X1, X2, X3 will say no. So here you can see here X1 is there, X2 is there. So actually only two variables are there. But in some examples we may have X1, X2, X3, more than two variables are also there. So in that case,
Yes.
we cannot use this graphical method, because in graphical method, we are using this graph, right? We are using this quadrant where we have only one x1 and x2. So, I mean, we have only two x's, right? So it's a two-dimensional. So when it's two-dimensional, we can use only for two variables, because we are showing one point on, I mean, one axis for one variable, other axis for other variable, and like that we are just finding it. So graphical method cannot be possible if your LPP, if our LPP, linear programming problems, are having more than two variables. Okay, so in that case we cannot go for graphical method. Now, apart from that, the advantages of the simplex method is what? We will get the every iteration in the simplex method. How we'll do the simplex method? In simplex method, main three things. The first is initialization. We have to initialize the method, and second thing, iteration. Will iterate within that method. So second step is iteration, and last step is termination. At certain point will terminate the method, and then the algorithm stops. So these are the three steps in this simplex method. Okay, so and every step, when we'll go in the iteration, every step will get a better and better answer. Okay, that I will show you now when we'll start with this. So let us start with this example, right? So now what we have to do, whenever we have to solve the examples in the tabular form, all these constraints are there now. These constraints we need to convert into a equation, because these are constraints. Why we are saying constraints? Because there is a condition that the LHS should be less than or equal to 5. The LHS should not be more than 5. So there is a constraint, right? So what we are going, we'll be converting this constraint into an equation. So that means what? X1 plus X2. Right now it's telling that it should be less than equal to 5. Now if we wanted to convert this less than equal to 5 by equal to 5, if we wanted to convert that by equal to 5, right, that means what? This should be equal to this. Now originally it is less than equal to 5. So what we are doing? We are adding one slack variable. Okay. Now here we have only two variables in original LPP. So we will start with the slack variables with x3. So we'll add one slack variable. Now what this x3 will be having? This x3 is just for equating this constraints. Suppose x1 and x2 addition of this is less than 4. I mean if it is equal to 4 and we want this should be equal to 5. So what should be the value of x3? It should be a 1. Right? So 4 plus 5, it will be equal to 5. Then we can convert the value, I mean we can convert the constraint into an equation. But this slack variable is not the part of our LPP. The original variables are only x1 and x2. They are the actually decision variables. This is called as a decision variables. So they are the actually decision variables. They are the original variables. This x3 is extra variable we have taken, which will help us to equate the constraints. So for this equation, we have added x3, and for this equation, we'll take another variable x1, 3x1 plus 2x2 plus x4 equal to 12. So this will do this just to convert that less than equal to equal to, we are using this x3 and x4. Okay. So we have seen now how we have converted this equation and this equation, I mean this constraint and this constraint into a equation by using a slack variable. Okay. Now what will happen if we are using slack variables in this constraint? What about the objective function? Our objective function is of maximization. So maximize z is equal to 6x1 plus 5x2. Now this is main function. Objective function is nothing but the main profit function or the loss function, right? That is the goal, objective. That is the goal or objective. So this is the objective function, which is telling that maximize means it is for profit. So whatever will be the value of x1, the 6 time will be the profit due to x1, and whatever will be the number of x2, 5 times will be the profit due to the x2. Now what about this slack variables when we are using into a constraint? What is their role into a objective function? So what we'll do into objective function, will multiply by 0, because they are not decision variables. So we'll multiply by 0. That means whatever the main constraints, main variables are there, that they only will participate into a objective functions, and all these slack variables which we have only used for equalization, which we have only used to convert into equation, they will not contribute into a objective function. So as they should not contribute into objective function, we are multiplying by 0. Okay. So right now we have converted this, and now what we have to do? Now we need to solve this. So whenever we'll start with this LPP, I mean tabular method, to solve by the tabular method, we should first convert all the constraint into the equation. Okay, so we have done this. Now we'll start for our see, now there are how many variables are there? X1, X2, X3 and X4. So total 4 variables are there. So simplex method by the simplex algorithm by the tabular method. Okay, so we need to write X1, X2, X3 and X4. Okay, and then we have here in this side we'll write down the variables, basic variables, which is called as a basic variables by xb, and for that basic variable their coefficient by cp. So we'll take that. Okay, so now whenever this is the initialization part, we'll say na initialization, iteration and termination. So these are the 3 steps in the simplex method: initialization, iteration and termination. So initialization is nothing but converting this and setting up the first iteration. So in this what we'll be doing, so when these are the basic variables. Now whenever we'll start simplex method by using this form, the basic variables will be always this slack variables which we have added. So from this equation, from this constraint, we'll take x3, and from this constraint we'll take x4, and then we have to write down the coefficients of, so for this the coefficients are 0, 0. Coefficients of x3 in objective function, coefficient of x4 in objective function, and coefficients of x1 and x2 in objective function. So here we have 6, here 5, here 0, here 0, and then we'll take RHS, and then we'll be having theta. So this will be our first phase. Now initialization, but we need to set up this matrix. So how to set up this matrix? For this is x3 belongs to first equation, right? This is the first equation. This is your first equation. This is your second equation. And after conversion also, this is the first equation and this is the second equation, right? So what we have to do? We have to take the coefficients of x1, x2 and x3. So x1 1, x2 1, x3 1. There is no x4 in this equation, so we'll take it as 0. Right hand side of this equation is 5, so we'll write down RHS is equal to 5. Okay, same way for the second equation, for this equation we'll write down the coefficients. See, for x1 3, x2 2, x3 2, there is no x3 in this, so 0, and for x4 is 1, and then 12. Okay, RHS is 12. So this is the initialization, and we have to see that these are these basic variables. Now for these basic variables we should always get the identity matrix. You can see that this is the identity matrix, right? Here x3 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 x4, here x3 x4. So we are getting identity matrix 1 0 0 1. 1 1 is there in the diagonal, so it is the identity matrix. So we are getting this identity matrix, right? So this is what the initialization. Now so zj, and then we have to calculate cj minus zj. Okay, so what is zj? Zj is nothing but dot product of this into this plus this into this. Okay, so I can show it, dot product of this into this plus this into this. So as here it is 0, the dot product will be always 0. So here zj will get 0. For this also will get 0. Here also will get 0. Here also will get 0. And we'll do a dot product of 0 into 5 plus 0 into 12. So this is also 0. Okay. So we'll get initially in the first phase, we'll get in the first iteration, we'll get all zeros. And now then we'll find out cj minus zj. So Cj is nothing but this. This is Cj, which is this one, 6500. Okay, so what we have to do? 6 minus 0 is 6. Okay, so we got Cj minus Zj. Now, once we finish Cj minus Zj, we have to go to the next iteration. Okay, so actually when algorithm will stop, when will not have any positive value over here. If some negative values are there and zeros are there, all negative or zero values are there, then algorithm will stop. We should have some positive value to go to the next iteration. Now in this case, leaving zeros, okay, don't bother about zero. In this case, we have two positive values, 6 and 5, right? So among this, we have to decide which variable will go into a next iteration. So among this 6 and 5, the one which is having the more positive will go into a next iteration. So in this case, the more positive is 6, right? So in the next iteration, this will go. This will go means what? X1 will go. In the next iteration, the X1 will go. But to go, only we have two constraints, means only two variables will be at a time. So either if X1 is going in the next iteration, X3 has to leave or X4 has to leave, right? So to decide that, we'll find out theta. So to find out theta, what is the formula? To find out the theta, the formula is RHS divided by corresponding element of entering variable. So this is RHS, which is entering variable, x1 is entering variable. What are their corresponding elements? 1 and 3, right? These are the corresponding elements of the entering variable. So what we have to do? 5 divided by 1. So here it will be 5, and 12 divided by 3. So 12 divided by 3 is 4. So we got 5 and 4. Now we have to decide which one is living. So when we wanted to decide a living variable, we have to take minimum theta. So among these 5 and 4, which one is minimum value? 4 is minimum value. So we'll be taking 4. So that means what? This will be living. Now this is living means what? X4 is living. So in the next iteration, when we'll write the next iteration, instead of X4, we'll be having X1. Okay, so whatever this living variable is there now, that is called, I mean this complete row is there now, which is living, this is called as a pivot row. So pivot element is the intersection element of entering variable, living variable, right? So this is entering column, this is living row. So where it is intersecting? It is intersecting at this. So this is your pivot pivot element. Okay, so generally we don't have to write everything, but we have to mark our pivot element. We can mention it as PE, pivot element. Okay, so this you have to mark with the circle or with the square or something. Okay, so this is your pivot element. Now in the next iteration, when we'll write down the next iteration, that's what x3 is as usual at its place. Instead of x4, x1 will be there. So x3 will write, I'll just write down one more row. So from here actually our second iteration is started. So now you can write down like this, or you people, because sometimes it confused. So what you can do, but again you have to write down the headings. So to avoid all those things, I will just continue always on the below this. But in some books, what they will do, they will write into a different tables. Again, they will mention another table. So now in the second iteration, now x3 will be at its place, and instead of x4, we'll write down x1. Okay, and as usual, what is the coefficient for x3? 0. What is the coefficient of x1? 6, right? So we'll write down 6. Now we have to find out these values. because in initialization it is easy to take from the constraints, but now it is different. So now when we go for the next iteration, first always we have to find out for the new variable. See, x3 is the old variable, it was there in the previous iteration also and this iteration. So x3 is newly, x1 is newly entered, so we'll find out for x1. How we'll find out for x1? Pivot row divided by pivot element. So this is our pivot row divided by this pivot element. So here 3 divided by 3, 1, 2 divided by 3, 2 by 3, 0 divided by 3, 0, 1 divided by 3, 1 by 3, and 12 divided by 3, 4. This is over with respect to x1. Okay, so always find out the first for the newly entered variable. How we'll find out? Pivot row divided by pivot element. Okay, so to find out for x3, you have to first understand that, see here, what are the basic variables? X3 and x1. These are the basic variables. So whatever the basic variables are there, for that we should get an identity matrix in the way they are appearing. So now see, here x1 is there and in the column here x1 is there. So x1, x1, this place we got 1. Now x1 and x3, this place we got 0. Same way, here x3 and x3. So at this place we should get 1. And here x3 and x1, here x1 and this x3, here we should get 0. We should get these values, okay, for this row. We are finding for this new x3, we need to find out the value. For this new x3, we'll take the old x3. So we'll take this row and this row. Okay, so we'll take old x3 and we'll take newly entered variable. Which is newly entered variable? X1. So we'll take x1. So always after finding this x1, I mean after finding this newly entered variable by pivot row divided by pivot element, whatever the remaining things we need to fill up, like now here we need to fill up this. For every time to find out this x3, we'll take always the old x3 from the previous iteration and we'll take this newly entered x1, this value. So we'll be concentrating on this row, we'll concentrating on this row and this row. Okay, and we'll find out we should get 0 over here and we should get 1 over here. Now see where we want 0. Here it's 1, here it is 1. So if you do 1 minus 1, we'll get 0. Okay?
Yes.
Okay. So same thing, same minus. If we apply over here, 1 minus 0, we'll get 1 over here. That means what? If we do a simple subtraction from the old x3's variables, from old x3 variables, if you subtract it new x1 variables, we are getting the desired answers which we are expecting in here and here. So we can use this simple subtraction for the remaining variables also. So remaining variables is this 1 minus 2 by 3. So 1 minus 2 by 3 means it is 3 minus 2, 1 by 3, right? So we'll get here 1 by 3. All such kind of calculations you should do at the rough side, back side in your answer script, or always you have to keep one page, rough page, and one page to solve this simplex method. This complete simplex method, one complete table, we should have one page and one page for rough work. Okay, and you should mention on the top rough work so that whoever the evaluator will be there, he will not consider that page You will consider only the actual page, okay, because lot of calculations you need to do. Now same way, 0 minus 1 by 3. So 0 minus 1 by 3 will get minus 1 by 3. And here 5 minus 4, so we'll get 1. So once we did this, then our next step is what? Calculate Zj and then calculate Cj minus Zj. This is coming as 6, this is coming as 4, 0, 2, 24. Okay, and now what we need to do? Cj minus Zj. So Cj minus, these are the Cj, right, on the top. So on the top, these are the Cj. So 6 minus 6, 0. 5 minus 4, 1. 0 minus 0, 0. 0 minus 2, minus 2. Okay, so our this iteration is over. But what we need to see, we have to again check with the Cj minus Zj value. Whether we have any positive values. This is 0, this is 0, this is minus. But we have 1, 1 is the positive value. So we still have this algorithm to continue. So here you can see, here we got one value, that is 0, and here we got next value, next Cj minus, Zj, we got Z value, that is 24. So first we got 0, that is initial feasible answer for the Z. Z is nothing but that max, our max objective function is there, no? Max Z. That is what we need to find out. So now in next iteration, which variable will be entering? This variable, right? So this will be entering, which is that variable x2. So in the next iteration, x2 will be entering, and which variable will be leaving? That's what we need to find out. So to find out that, what we'll use? We'll calculate the theta, right? We need to calculate theta. How will calculate theta? RHS divided by corresponding elements of entering variable. So RHS is 1 divided by 1 by 3. So that will be 3. And here 4 divided by 2 by 3. That means 4 3s are 12, 12 by 2, 6. Right, so we got two values for theta. Which are those two values? 3 and 6. Now among these two values, which one is minimum? 3 is minimum. So will be, that means what? This is leaving. This is now a pivot row. As this is a pivot row, and this is this is the entering variable, and this is the leaving variable, which is pivot element. This is our pivot element. Okay, so now in the next iteration, instead of x3, we will be having x2. What are its coefficient? In the coefficient for this is 5, and for coefficient for this is 6, right? And then we need to find out the values for this and values for this. So which one will find out first? x2, because x2 is newly entered, right? So for newly entered variable, we'll find out first. How we'll find out? We have to give for the previous iteration, and we have to check which is pivot row. So this is pivot row, and which is pivot element? This is pivot element. So pivot row divided by pivot element means 0 divided by 1 by 3. So at this place, 0 divided by 1 by 3, so it will be 0. 1 by 3 divided by 1 by 3, so this is 1. 1 divided by 1 by 3, so it is 3, minus 1 by 3 divided by 1 by 3, so it is minus 1. And here 1 divided by 1 by 3, so it is 3. So this you will get very easily by saying pivot row divided by pivot element. Now we need to find out for x1. So as usual, to find for x1, okay, now we need to find out whether we have to do plus, minus, what and all. So now see x1, x1. We should get 1 over here, x1, x2. We should get 0. So we should get this value because these are the basic variables. No? So for this basic variable, always in this matrix, we should get the identity matrix. So we are getting identity matrix. So that's what. So how we'll get 1 and 0 over here? So which are the two rows we have to take? We have to take this new x2 and old x1. This is old x1. So we have to take this and this. Now concentrate where you want 0 over here. Always first concentrate where you want 0. You want 0 over here. So here we have 1 and here we have 2 by 3. So if we do 2 by 3 minus 1, will not get 0 if we do simple subtraction. But if you want 0 over here, then this value also should be same as 2 by 3, right? This is old x1, 2 by 3. So what we can do? We can multiply this 1 by 2 by 3. So 1 into 2 by 3, it will be 2 by 3. And then we'll subtract from this 2 by 3. So it will be 0. So we'll get 0. Now same thing, if you are multiplying this 1 by 2 by 3, then you have to multiply for all the row by 2 by 3. So if you multiply this 0 by 2 by 3, and then if you subtract from 1, we'll get 1 over here. That means what is our formula? You have to multiply these values of x2 by 2 by 3, and then you have to subtract from the x1. So this is the formula which we need to apply to get the values of x1, right? So same thing will apply for the remaining three places also. So multiply this 3 by 2 by 3. So 3 gets cancelled, only 2 will be left out, and subtract from the x1. x1 is where? 0. So 0 minus 2 will be minus 2. Same thing, multiply this minus 1 by 2 by 3. So if you multiply by minus 1 by 2 by 3, it will be minus 2 by 3. Minus minus plus. So plus 2 by 3. So what will happen? What we have to do? 1 by 3 plus 2 by 3. 1 by 3 minus 2 by 3. So it will be 1 by 3 plus 2 by 3. So it will be 3 by 3. So it will be 1. So this will be 1. Same thing we have to do here also. So multiply this 3 by 2 by 3. So 3 gets cancelled. 2 will be there. Subtract from 4. 4 minus 2. So we'll get it over here 2. Right? This part you have to do carefully. In this whole simplex method, this is the part which you need to do with little carefully. If you do this clearly, then there is no difficulty in this particular simplex method. So we finish with this now. We have set up. Now we need to find out Zj, and then we need to find out Cj minus Zj. So first we'll find out Zj. 5 into 0 plus 6 into 1. So it will be 6. 5 into 1 plus 6 into 0. So this will be 5. Then 5 into 3 plus 6 into minus 2. That means 5 into 3, 15 minus 12. So it will be 3. And this is 5 into minus 1. So that is minus 5 plus 6. So it will be 1. And this will be 5 into 3 plus 6 into 2. So 15 plus 12. So this will be 27. Right? Now we got this. What we have to do? Cj minus Zj. So Cj is the top values, right? So 6 minus 6, 0. 5 minus 5, 0. 0 minus 3, minus 3. 0 minus 1, minus 1. Here we don't have to do anything. So this is complete with Cj minus Zj. Now concentrate on this Cj minus Zj value. Do you have any positive value over here?
No, ma'am.
No. That means what? Terminate. Algorithm is getting terminated. The algorithm will stop here now. The solution, we got the solution. So now you can see over here, first we got 0 answer, then we got 24, and now we got 27. So every iteration the answer is getting maximized, and our this one is also for maximization. So every iteration we are getting maximum value, right? And the final iteration value is the highest value. So the answers we need to write: z is equal to what, x1 is equal to what, and x2 is equal to what. This you need to always highlight. So after finishing this table, at the bottom you have to write, so z is equal to this last value 27. Now x1 is what? So in last iteration, in the basic variable we have x1. So for this x1, what is the right hand side value? 2. So x1 is equal to 2. In last iteration we have x2. So what is the RHS? 3. So x2 is equal to 3. So we got x1, x2. Suppose in the large iteration we have x1 but we don't have x2. If we have x3 or something like that, okay, suppose in case, then what will be the value of x2? 0. That's all. You don't have to go check previous iteration anywhere we got x2 or odd. If there is no x2, then if instead of this x2 if it is x3, then there is no x2, right? Then x2 will be 0. If there is no x1 in this iteration, then x1 will be 0. But luckily in this particular example we have a x2, right? So this is our x2. We have x2. So x1 RHS value 2, x2 RHS value 3. So this is our final answer. Then we can cross check this. See, our Z max is what? Our Z max is 6x1 plus 5x2. This is our objective function, right? So now in this objective function, if you put this values, what is the x1 is equal to 2. So 6 into 2, how much it will be? 12. Put the value of x2. What is x2? 3. So x2 is equal to 3. 5 into 3, 15. 12 into 15, 12 plus 15, 27. So z max is equal to 27. We got z is equal to 27. So it is correct. So just for a cross check, not necessary, you don't have to write this thing, just for our satisfaction, whether whatever the x1 and x2 values we got, whether it is correct or not. So we can put into this objective function and we can clarify. So it is, we are getting the same answer, so it is correct. Okay. So this is the way you have to solve the simplex method by the tabular form.